In this series of videos, we're going to solve trig equations, and the more practice we get, the easier it's going to be for us to do this on our own and to be able to solve in all different sorts of situations. So I'm going to try and expose you to as many different situations as I can. First, we're going to start with the first step. Is we always want to have the same trig function and the same angle. So we always want the same trig function and the same angle. So if there's an identity that we can use, some type of algebraic skill that we can use, substitution perhaps, to try and attain this, that's what we want to do. Then what we want to do is try to isolate our trig function and or use the zero product property. So that we can solve. So the first thing is in this very first example, 2 plus sine of theta equals 3 over 2. There's only one term that has a trig function. So we don't have to worry about getting multiple terms to be the same trig function, and there's only one angle. So we'll get to go straight to isolating the trig function. How we're going to do that is we're going to subtract 2 from both sides. Now when I subtract 2 from both sides, I'm going to get the sine of theta is equal to negative 1/2. I made it a common denominator and subtracted the fractions to get negative 1/2. Then we ask ourselves, we want to solve this in the interval 0 to 2 pi. So where is, in which quadrant will the sine give us a negative ratio? Well, that's going to happen in both quadrants 3 and 4. Then we say, what angle is going to give us a 1/2 for a ratio for sine? Well, that's going to happen when y is 1/2, and when y is 1/2, x is the square root of 3 over 2, and that is a pi over 6 angle. And the pi over 6 angle in quadrant 3 is 7 pi over 6, and the pi over 6 angle in quadrant 4 is 11 pi over 6. And that's how we get our two answers for theta. So let's try another. We have negative 1 plus cosine of theta equals negative 2 minus the square root of 2 all over 2. Once again, we only have one term, so we only have one trig function and one angle. So we can go straight to isolating that trig term all by itself. So we're going to add 1 to both sides, and I get cosine of theta equals negative 2 minus the square root of 2 over 2 plus 1. Now I'm going to rewrite this. Negative 2 over 2 minus the square root of 2 plus 1. Negative 2 over 2 is negative 1. Negative 1 plus 1 cancels out, and we have negative square root of 2 over 2 is equal to cosine of theta. Now, in what quadrants will we have a negative ratio for cosine? Well, that happens in quadrants 2 and 3. And the angle in quadrants 2 and 3 that give us a ratio of square root of 2 over 2 is our pi over 4 angle. And our pi over 4 angle in quadrant 2 is 3 pi over 4. And the pi over 4 angle in quadrant 3 is 5 pi over 4. So our answer is theta is equal to 3 pi over 4 and 5 pi over 4. So what we're doing here is reinforcing our angles, our unit circle, and our quadrants, which functions are positive and which quadrants, going around that unit circle. We'll do a couple more on this video. We have 1/4 times cosine of theta equals 1/2. At any point in time, press pause and try and do the problem for yourself if you'd like, and then come back and check your answer. Here we have 1/4 times cosine of theta equals 1/2. So to isolate cosine of theta, I'm going to multiply both sides by 4. That's going to give me cosine of theta on the left, and it's going to give me a 2 on the right. Now, where is the cosine of theta going to give me a ratio of 2? Well, the range for cosine of theta, let's see, our range, cosine starts at the max, ends at the max, halfway through it's at a min, so the minimum value is -1 and the maximum value is +1. This value of 2 is outside the range for cosine of theta. Therefore, there is no solution. Now, the reason why we say no solution here, and we don't say undefined, is because of this word right here. It's asking us in the directions to solve for theta, and there is no solution. Okay, here's another. We have -9 times the tangent of theta is equal to -3 times the square root of 3. We want to solve for tangent of, well, we want to isolate tangent of theta, and we want to solve first for the angle theta. So I'm going to divide both sides by -9, giving me tangent of theta on the left, and -3 times the square root of 3 over -9 is going to be a positive square root of 3 over 3. And that comes from 1 over the square root of 3. So the ordered pair that's going to give me a positive, the quadrant that's going to give me a positive ratio for tangent, that's going to be quadrants 1 and 3. And the ordered pair that's going to give us 1 over the square root of 3 for tangent will be this ordered pair right here. And that is a pi/6 angle. So we're looking at the pi/6 angle in quadrant 1 and the pi/6 angle in quadrant 3. That's pi/6, and these actually happen to be a pi apart. So that is 7 pi/6. So theta is equal to pi/6 and 7 pi/6.